before you start today's assignment. So for our quadratic below, we want to find the y value when x is -2. So here's my equation, and notice it's graphed in blue over here on the right. If I want to find the y value when x is -2, I'm going to replace all the x's in my equation with -2. So I'm going to type 2 times -2. So whenever I substitute a number, I want to put a parenthesis around it. And then I'm going to do raised to the power of 2. And then I'm going to press tab so that I get out of the exponent, minus 8 times -2 plus 3. And then I can see at the lower corner of this rectangle that my answer is 27. Now, what does that mean? Well, that means that if I were to go to the graph, and if I were to go to the point -2, 27. All right, so here's -2, 27. I'll get as close as I can. It's hard to get exactly on there. There you go, -2, 27. It's a point on my graph. Now, if I want to plot a bunch of points like you're going to do in your assignment, what I want to do is make a table using Desmos. So what I can do is I can click on this little gear button up here at the top, and next to my equation, I'm just going to press table. So I can still see the equation up here over on the y column, but notice here I have a bunch of ordered pairs, and you can see Desmos plots the points in your table. Now, normally we want some points on both sides of the U, or the parabola, that's the name of our graph, and so we can always go into our table and we can either type over the ones we don't want or we can add to it. So things like 3, 4, that's probably pretty good, 3, 4, 5. You can see the points on that graph. And then we can complete our graph by plotting the points. So notice that these ordered pairs represents a point on the graph. So for example, this point right here is 0, 3, and that matches the third line in my table. Now, the other thing I want to think about is, what is the domain of my graph? Well, domain, remember, has to do with x values. And so we're thinking about what numbers am I allowed to plug in for x? Well, I have some numbers in my table, but I could also add a bunch of others. I could add 1.3. I get an answer for y. I could put in 275. Notice that my y value is really, really huge. I'm not going to want to graph it, but I can plug in a really big x value. I can also do negative values like -64. Again, I'm going to get a really big answer. I won't want to plot it. But the idea is I can plug anything I want for x and I'll get an answer. So that's why we say the domain of every quadratic equation or every parabola is all real numbers. Now, what about the range? Well, the y values, if you take a look here, my y values go down, touch the bottom of the u, and come back up again. So my range does have a lowest value in this case. So I'm going to touch that bottom point of the u, which we call the vertex, and that's the point 2, -5. -5 is the smallest y value on my graph. So if I type that in, my y values are greater than or equal to -5. Notice that the green shaded part covers my graph perfectly. All right, and notice that it starts right at this vertex, at this point on the u, where it turns directions, and I can see that this number is the smallest y value. All right, on our quiz, I made it a little bit too high in that case, but a little bit off, because notice here, if I went -8, it still covers up my graph, but it covers up too much. There's no points where the y value is between -5 and -8. That's too much. So my range should just cover my parabola perfectly. And so my range is y is greater than or equal to -5. And review a little bit of domain and range. So let's say I'm taking a look at this equation I have over here on the left side. Y equals 2x squared minus 8x plus 3. Let's say I want to fill out a table. And the first thing I want to know is I want to find the y value when x is -2. So when I plug that into my equation, I'm going to replace all my x's with -2, and I want to make sure I use parentheses. So I would have 2 times, and I'm going to replace the x with -2. And then we want to square it. And then we will do minus 8 times my x, and then plus 3. And over here on at the bottom of that rectangle, we can see it's 27, and I can't see it because I haven't gone high enough. So if I scroll my graph up here, I can see that I have this point right here when x is -2, really close here. Y is 27. All right. Now, normally we want points a little bit closer to this transition point where it stops going down and starts going up. And so remember, when Desmos, if we want to make a table quickly so we can plot some points on graph paper, remember what we can do is we can click on our wheel, and next to our equation here, I can just pick table. So the equation's still shown up here, but it gives you values. Here's that -227 that I did by hand. You can also see right in the graph here, all right, we can see these points from the table that they plotted for us. But I notice I want some set points past this low point. So I'm going to add to the table 3, 4, 5. And again, I can see that Desmos adds more points to my graph. And I can add whatever x's I want depending on the table I'm supposed to fill out on my paper. So that's the first thing I want you to remember. The second thing I want you to think about is when we're thinking about a graph and we're thinking about domain and range, remember that domain is all the numbers I'm allowed to use for x. And if you take a look at it, I could pick any number I want and I could add it to my table. So I could add 1.3 and I get an answer. I could add 152 and I get a really huge answer. I'm not going to want to graph, but there is a point there. I could do -73. So the idea in domain is that I can plug anything I want in for x. So my domain is all real numbers. I can't see every point because as you notice in the table, some of our y values get kind of big. And so we're not going to fit them all in the graph, but that doesn't mean we can't use those numbers. They're just hard to plot. So remember, our domain is all real numbers for every parabola, for every quadratic that we have here. Remember that the shape of this graph is called a quadratic. All right, no, the equation is a quadratic, excuse me, the graph is a parabola. Now range, remember range is the y values on the graph. And on the quiz you took yesterday, there was a little bit of confusion, it wasn't meant to be. But one thing I said is you can always test using Desmos to see if you're right. So the first thing I want to take a look here is I want to look at this low point. And I can see that my low point happens at 2, -5. So that means that my y values, all right, are either above that point or below. And I can see that my graph goes up. So I want to say my y values are greater than or equal to -5. Okay, so notice it covers just the graph. On the quiz, what I did was I went a little bit beyond that so that it would still cover the graph. Like what if I said instead -6? Sure, it still covers the graph, but if you look, there's some space right in here where there's no points on my parabola. The lowest point on my graph is this point where it turns, the bottom of the U or the top of the U. -5 is the smallest y value. So what I want to do is I want to make sure when I test this with Desmos that my shaded part just covers the graph. It doesn't go too low or too high. It's just covering all those y values on the graph. So my range is y is greater than or equal to -5. I hope this helps as you work on today's assignment.